The selection of an appropriate global transfer function for the visualization of time-varying volume data can be a challenge, especially if the global data range is not known in advance. Data range may vary dramatically between time steps, thus applying a local transfer function to every time step may result in inconsistent coloring. Here we show an example sequence where a local transfer function is applied to each time step of the argon bubble dataset. Different data ranges in the data are not assigned the same colors throughout the simulation, resulting in inconsistent coloring. Compare the images produced with the local transfer function to those produced with the global transfer function, where the data ranges are colored consistently throughout the simulation. In this paper, we present an image-based technique for exploring the transfer function space of time-varying volume data in a coherent manner. We achieve this by storing a small amount of extra information at rendering time, which allows us to later explore the transfer function space without accessing the original 3D data. We can perform color space remapping from local to global range to achieve consistent classification between time steps. Here we demonstrate the remapping results. The coloring is consistent with the global range. Here we show the remapped sequence of the argon bubble dataset. We achieve consistent recoloring throughout the entire sequence using our image-based technique. Now we change the opacity and color to bring out the torus-shaped feature of interest. We now demonstrate how the changes to opacity and color are applied coherently to all time steps. Now we add a color to highlight the variation of high intensity in the scalar field. We demonstrate the interactive exploration of time-varying volume data. The navigation bar lets users switch between time steps in real time. Blue regions on the navigation bar indicate cached time steps. Users can now explore the entire time sequence and the transfer function space in real time. The changes are applied coherently to all time steps in the sequence. We provide an additional example of exploration of the combustion dataset in the transfer function space. We first change the color of every feature in the dataset and continue by changing the opacity of every feature.